Okay, so now I'm going to do the Panda board preparation. For this I'll need a Panda board, revision A2 or later, four 440 by 3/8 hex standoffs with a male and female end, four 440 nuts, and four lock washers, two pieces of male 0.1 inch header, dual row, with 2 rows of 14 pins each. Those are going to be soldered on as the extension connectors on the Panda board. Here we have a product that's sold as the USB extension to be added inside your PC if you have extra USB ports, and that's where we're going to get extra USB A type male connectors for the Panda board. Then for the fan assembly to cool the Panda board, we have the fan here. I forgot the dimensions off the top of my head. The fan will connect, it's a 12-volt fan, and so we have a JST RCY connector, male, with pre-attached leads, and then we have a JST RCY female. These are 2-pin connectors with the crimp pins. We get those from Palulu, and two pieces of, that's 3/32 heat shrink tubing, and then the 3D printed fan bracket. And so this will enable us to connect the fan to the DC battery voltage power takeoff on the orangutan board, and that will power the fan but also provide a pass-through for additional battery voltage power devices like the Kinect. Then for the cable assembly that actually supplies power to the Panda board, here we have two 8-inch lengths of 20 gauge high flex wire with silicone insulation. We get this from I forgot. And we have a 2.1 millimeter inside diameter by 5.5 millimeter outside diameter DC coaxial power plug, a 2-pin female Spox connector with the 2 crimp pins, and some bits of heat shrink tubing, a 3/16 by 1/2 inch length, and this is a 1/4 by 1/2 inch. We're actually only going to use half of that. For tools, we've got the heaterizer for heat shrink tubing, flush cutter, pliers, needle nose, the flux pen, wire stripper, small flathead screwdriver, and the regular Phillips screwdriver, some Scotch tape, Mr. Hands, and a soldering iron set at 350. And we're also going to need the crimping tool. So let's get started with some of the cable assemblies. So I'll move the Panda board out of the way and I'll zoom in. So we'll make the, let's work on, the easiest one is the USB-A cable assembly, so I'll just unscrew these. You can buy panel mount USB-A connectors, but I found that the prices are generally fairly surprising. So an inexpensive way to get the same component is to buy these extension headers made for PCs, and there are landings for both on the mezzanine board of the OHM robot for 2 of these. This screw is being a little difficult. Let's see if I can do it. It's been, for some reason they added a thread lock on these. There we go. And so we won't be using those screws. Set that aside. And the connector already has the lead wires in the correct order, but it has, usually they connect, this is usually the case anyway, they connect the shield also, and in the recent revisions of the Panda board, I think maybe all revisions of the Panda board, that pin is no longer actually a shield, and so I'm going to just pull that out using the small screwdriver to help me free that pin without damaging it, and I'm going to actually tape that aside. So it'll work fine, but the shield won't be connected. Do the same with the other one. So if you just, without breaking it, you can lift up the plastic tab that holds this in place. Recalcitrant. There we go. And then pull that pin out. Okay, so I've prepared these 2 USB-A connectors, and I'm going to set them aside. Now next I will work on the DC power cable for the Panda board. So I've got my 2 8-inch lengths of 20 gauge wire and my DC barrel jack, barrel plug, and I'll strip these wires just a touch on either end. And I will tin them. With a little flux, the high gauge, low gauge wires solder a lot better with a bit of flux. Before I forget, I will slip the cover of the barrel plug onto the wires, and then it's a center positive connection. Eventually I'll tin the connector too. Too much solder there. Okay. So there's the outside. The negative terminal. It's the outside of the connector. And the positive terminal goes to the inside conductor. Make sure they're not shorted, of course. There's no free bits of conductive material. And just gently, not too tight, fold down the flaps on the connector. Being careful not to puncture the insulation, the wire insulation. And screw on cover. Okay, and on the other end, first thing I'll do is I'll take my 3/16 diameter heat shrink tubing, 1/2 inch length, and I'll slide that on the wire. I'll take my 1/4 inch heat shrink tubing, this is a 1/2 inch length, I'm going to cut that in half to make about a, actually this is a, I'm going to make it about 3/8 of an inch, 1/4 to 3/8 of an inch long, and slide that on. We will shrink those down later. Okay, next I will crimp on the two female Spox connectors. I actually forgot. We shouldn't have the wires tinned for that, so I'm just going to chop off the very ends and restrip those. If the wires are tinned, then the crimp will be kind of bulky, and sometimes it doesn't insert into the connector. And so insert the wire, get the crimp started with the pliers. That's the way I like to do it. Takes a little practice. And then finish with the crimping tool, where we go just until the tool releases itself. And maybe I'll give it just a little bit more in this case. Actually, I'm in the wrong slot. I'll go to the smaller slot. Try not to break through the insulation same process with the other terminal. Try to make sure the crimp is very tight. Okay, now I'm going to insert the DC power wires for the Panda board into the 2-pin female Spock's connector. And they do have an orientation, so you have to look at there's a very tiny little catch that's going to have to go into one of these slots here to make sure it's oriented that way. The connector itself is polarized, so make sure that the notch in the connector, we're going to orient that down. And in that orientation, the red wire goes into the far slot. And if it won't go in, you may have to use the pliers to tighten up the crimp connector. And the black wire goes to the near slot. So this one is not going in. So I'm just going to tighten that up slightly. And the wires, the insulation tends to split, so I use the small screwdriver to push on the metal part of the connector to get it to go in. And they shouldn't pull out because the catches have engaged those little slots. Okay, and then 2 parts of heat shrink. So first the 3/16 diameter heat shrink. Just strengthen the wires by holding them together. Make sure that, of course, the wires are fully insulated so that the red and black wires won't contact each other, of course. If there's none of the strands of the conductor are outside the crimp. And then the larger piece of 1/4-inch diameter heat shrink, I'm going to work over the outside of the Spock's connector. Not really far, but just a bit. Can't go too far or it would impede the connector from being inserted into its socket. And then I'm going to shrink that down. And that'll provide some strain relief as the wires flex. So there's the completed power cable. for the Panda board that takes power from the auxiliary supply on the orangutan board, 5 volts, and supplies it to the Panda. So the next thing I'm going to do is prepare the fan. So I'll take my fan here. It comes with its own leads. I'm going to trim, they're even pre-tinned. I'm going to trim them a little bit. Try not to let those trimmed bits clutter your work area in case you don't want them to get stuck on a circuit board. And this is the male JST RCY connector with leads, and I'm going to cut those leads about 1 inch on from their end. Then I'm going to strip the remaining ends. I'm also going to strip the 1-inch cut ends. And on here, I'm going to crimp on the female JST connector. We're making a pass-through cable here. So this female connector will connect to the battery power takeoff on the org. In a minute we'll resolder that together back onto that male JST connector with leads that's sitting in Mr. Hand's right now. And also at those solder points we'll tack on the fan leads. It's a bit larger, so it's a little easier to work with and crimp than the. So I have one conductor that was sticking out. Make sure that doesn't go anywhere. It's a little easier to crimp than the Spock's connector that we just did. Try to get every strand of the conductor into the crimp. If you don't have a crimping tool, it can be done only with needle nose pliers. Be careful. Tighten them up. So the idea is to make a pass-through connector, and so one way to make sure we get the polarity right is actually insert this into the insert the female end into the end of the male connector, and then we can make sure that black goes to black. I won't actually fully insert them yet. I'll just get them started. And again, these have a little tab that you're going to have to make sure engages so they can click in and lock in. Okay, so black to black and red to red. Now, just pull that out and I'll seat both of these connectors. These are the female pins. Remains is to solder all of the wires together. So I'm going to take the red fan lead and line it up with the red lead on the male JST RCY. I'm going to slide one of the heat shrinks over that and slide it way down so that the heat from the soldering doesn't start shrinking it. And the same with the black. Flux. It's always tricky to solder 3 wires together. Avoid it if possible. But it's also tricky to strip a portion of wire in the middle. So that's one of the reasons that I cut the wires. Looks like an okay joint. Flux. See, that went much better because I was using Mr. Hands and I was holding the wires closer to the point where we were making the connection. Slide the heat shrink back down over those connections. And then the final step of the fan prep is to press the fan clip onto the fan, and this has to be done in the correct orientation. So get the fan with the label down, because it actually blows the air in the direction of the label, and I like to put the lead wires in the lower right like this, and then take the fan clip with the clip part in the upper right and gently ease it down over the fan. The fan's quite delicate, and we have seen some of them fracture while we do this, so go slowly, get it started. Go. Work it down over the fan just till the point where it's flush. Then I flip it over and I flush it out by pushing against the table. Make sure the fan still spins, of course. So there's the completed fan assembly with pass-through connector for the Panda board. Okay, now finally I'm going to prepare the Panda board itself. It's a fine pitch multi-layer board, so we should be quite careful. First thing I'm going to do is solder on the extension connectors, put them in place and hold them with a little tape. One of them came out. And I just solder one pin on each, just to hold it, and that'll work better than the tape. Take the tape off. And now I can remelt that solder and adjust the connectors so that they're flush and vertical. Stay on. And now I'll solder another corner on the opposite end of the connector. Check that they're still flush. And now I'll solder all of the connections. These are the expansion headers for the Panda board. Currently we're only using them for the two USB expansions. The Panda board has two USB connectors built in, but it actually has 4 exposed USB signal pairs. So besides the 2 built-in connectors, the remaining 2 are provided on this expansion connector. go. Check for any shorts, bad connections. Looks okay. So now the next step is just peel off the rubber feet that are provided. We're going to replace these with standoffs. And then in the 4 extremal corners of the board we'll place our 440 by 3/8 long standoffs. Take the male end of the standoff and use a washer and nut. Just gently tighten. Okay, and there's our completed Panda board, and the fan will be held actually by the mezzanine board, but it'll be about here, and that's the main processor, and the DC power connection of course plugs in here, and then this will get power from the orangutan board, which will be about up here. And the USB extension connectors plug in there.